Hi, in the last video, I discussed about how do we solve a pair of first order ordinary differential equation by using eigenvalue method, right? So we found the eigenvalue that were, so in the last example, that was both of the eigenvalues were complex. Actually, they were conjugate to each other, right? And then we found the eigenvector for that complex eigenvalue, and we found that if the real part of the eigenvalue, that is mu here, right? So if the mu is negative, then the origin is stable, and then the solution will spiral in, right? Because whenever you start the solution, it was going like circling a little bit and then going towards the origin. So it was stable with spiral in. Okay, so I'm going to give you a couple more examples where the if what happens if the real part, that mu of the eigenvalue, is positive, or if mu is 0. We will see both type of example there. Okay, guys. All right, so let us first start with this example. We have solve y double prime minus 8y plus 17y equals to 0. Also draw the direction field to see the behavior of the solution when t tends to infinity. So we first change this second order equation into the system of two first order linear ODEs, right? So how do I do that? Is you just say let x1 equals to y and then x2 equals to y prime, right? So what do you get? If you find the derivative, you will get x1 prime equals to y prime, right? So what is y prime? Y prime is basically x2. Now if you find out x2 prime, what do you get? x2 prime equals to y double prime. Now if you solve the given equation for y double prime, you will get negative 17y and then plus 8y prime, right? So what you get basically is x1 prime equals to x2, right? And then x2 prime equals to negative 17x1 because y is x1, right? And then plus 8x2. Okay, so let us write down this in the matrix form. What do you get is x1 x2 x2 and then prime is equals to, let us write down that, because this x2 is like, you can think that as 0x1 plus 1x2, right? So you can write that as 0 1 0, you don't need comma there, so 0 and then 1, and then for the second equation you get negative 17 and then other one is 8, right? And then you can write this as x1 x2. This is a homogeneous equation, right? Because there is no constant term on the right hand side. All right, so what is A? Matrix A is, you can write 0 1 negative 17 and then 8. You see that? Now how to find out the eigenvalues is, to find out the eigenvalue, first of all you need to find out the characteristic equation, right? Characteristic equation is, it is lambda square and then minus sum of those two numbers, that is the trace, right? Sum of those two is 8 lambda, and then plus this is the determinant of A. How do I find out the determinant? You multiply this positively and you multiply this negatively. That means plus 17, because see 0 times 8 is 0 minus negative 17 times 1 is negative 17. So minus negative 17 will make it positive 17, right? Now I need to solve this. Lambda equals to negative b, that will be, this is a quadratic, so I'm using the quadratic formula there, right? So what you get is 8 and then plus minus under the root b square, 80 square, minus 4ac, you see that, divide by 2a. Okay, so it is 8 plus minus, how much is that? 80 square is 64 minus 4 times 4ac, right? So 4 times 1 is 4 times 17 is 68. 64 minus 68 is negative 4. Okay, divide by 2. So what you get is 8 plus minus, how much is that? That is 2i, because there is a negative number under the root, right? Over 2. So if you simplify this, you will get 4 plus minus I. So 4 plus I and 4 minus I are the two, basically they are the two two eigenvalues, right? So what we need to do next is we need to find out the eigenvalues, eigenvector for that. So for lambda equals to 4 plus I, so what do you get? Let V equals to, let's say the eigenvector is V equals to, let's say V1, V2. Let us suppose that V1, V2 is the eigenvector. Then what happens? Then AV equals to lambda V. To find out the vector V, that's what we do, right? What is A? So your A is 0, 1, negative 17, and then 8, right? And then V is V1, V2, right? Equals to lambda is 4 plus I, right? And then V is again V1, V2. That's what you get. Now you simplify. How do I multiply these two matrices? Is 0 times V1 is 0 plus 1 times V2 is just V2. And then what is the second one? Negative 17. Negative 17 V1 plus 8 V2. That's the left hand side, right? And equals to 4 plus I times V1. And then 4 plus I times V2, right? And then this is also a matrix. Now you compare, you just set the first component equals to the first component, and the second component equals second component. So you can pick any one of those, okay? Since the first one is easier to do, so I'm doing that. So V1 is equals to 4 plus I, and then V2 equals to 4 plus I times V1. Set V1 equals to 1, you get V2 equals to what? V2 is 4 plus I. So the eigenvector is V equals to 1 and then 4 plus I. That is V1, V2, right? Hence the solution is you can write x, let's say this is x1, okay? X1 vector is equals to what? E to the lambda t and then times V, right? What do you get? You get e to the 4 plus I times t times 1 and then 4 plus I. Okay guys, now so this is x1. Let me write inside the parentheses just to tell you that for one eigenvalue you get one set of solution, for another eigenvalue you will get another set of solution, okay? So similarly, what I'm going to do here is you will try this similarly, okay? Similarly for lambda equals to 4 minus I, if you do all these steps, okay, all this from here to all these steps, we get the eigenvector V will be 1 and then 4 minus I, because the conjugate of that eigenvector will be the eigenvector for the conjugate eigenvalue, okay? Now this is the V, okay? Now what we are going to do here is, so what will be the solution in that case? And the solution, let's denote this by vector x and then the 2, okay? I'm just saying that this is the second solution for the second eigenvalue, okay? And the second eigenvector. So you will get this eigenvector will be e to the 4 plus I times t, right? And then what is the eigenvector? It is 1 and then 4 minus I. Okay guys, so this is what you get for the eigenvalue and eigenvector and the solution. So we got the two solutions here. Okay guys, now what I'm going to do next is I want to find out the I want to write the solution, the let's say so let's say next what I want to do is I want to write, do you remember that what I said is after you find out x1 or x2, you try to simplify this using the Euler's theorem, and then Euler's formula, try to simplify this and then write in the form of u plus iw. That's what you would try, okay? So how do I do that? Is next x1 is e to the 4t times e to the it, right? It, and then you can write 1 and 4 plus I. You see that? What did I do? Because e to the 4 plus I times t is, you can distribute that t to 4t and then it, and then since this is plus in the exponent, so you can write e to the that times e to that. Okay, so what do you get there? Then you get e to the 4t, right? And then how do I simplify this? So e to the it can be written as cosine t plus I sine t, right? Cosine, that's the Euler formula. We used it last time, right? I sine t, right? And then there is 1 and 4 plus I is still there. Okay, now if you simplify this, what do you get? You get e to the 4t is there outside, right? You just distribute these two inside 1. That will give you cosine of t plus I sine t when you multiply with 1. Now if you multiply with 4 plus I, you will have to FOIL, right? How do I FOIL? Cosine t plus 4 is 4 cosine of t, right? And then cosine t plus I is plus I cosine of t, right? And then I sine t plus 4 will be plus 4I sine t, and then I times I sine t will be plus I square sine t. This is the matrix you get when you multiply these two, when you FOIL these two terms. Okay, now so what you can do here is you can still write e to the 4t, okay, and then there is cosine t plus I sine t. What I'm trying to do here is I want to group the term with I in one place and then not I in other place. What is the value of I squared? -1, right? So what you can write here is 4 cosine t minus sine t. You see that? 4 cosine t minus sine t, and then plus the remaining one, the middle two terms will have I. So cosine t plus 4 sine t. You see that? This is what you get. So that is the whole parenthesis there. Okay. Now if you simplify, if you write that into the sum of two matrices and then you just distribute this inside, what do you get? You get e to the 4t cosine of t, and then 4 cosine of t minus sine t is 1 also there is e to the 4t. Okay, and then let me write that nicely. So 4 and then e to the 4t and then cosine of t. So I'm multiplying this with all these terms and all these terms, but I'm writing in the sum of two matrices, one with I and other without I, and then minus e to the 4t sine t is one matrix, and I will write for this one and that one plus I times, do that, e to the 4t times e to the 4t sine t, right? And then e to the 4t cosine t, e to the 4t cosine of t plus 4 e to the 4t sine t. That is the second matrix you get. Okay, so you got, basically it is in the form of u plus iw. That is in the form of u plus iw. Okay guys, so we were taking the very first the solution, and then we are able to write in the form of u plus iw there. Okay, similarly if you take the second solution and then do the same thing, you will get u minus iw format there. Okay, similarly if you take x2 because x sub 2 is basically the second equation, right? That's why I'm just writing this x and then superscript 2 inside the parenthesis, just to tell that this is the second solution. Okay, so you will get u minus iw. Okay, you will get exactly the same vector for u, exactly same vector for w, but you will see negative sign in the middle. Okay guys, so how do I find out the general solution? To find out the general solution, first of all you need to check what is the value of the Wronskian, right? So what do you do there then? So what you can do there is next what you do is Wronskian of uv is equals to, what you do is you write down the vector u and then uw, right? You write down the vector u and you write down the vector w. Okay, so what do you do that? That's the determinant, right? E to the 4t cosine t, and then what is next? E to the 4t sine t, right? And then similarly you do 4 e to the 4t cosine t minus e to the 4t e to the 4t 4t sine t. That is the first one, right? And the second one is also you can write e to the 4t cosine t plus 4 e to the 4t sine t. That is the determinant. So if you find out this, how do you find out that? You multiply this with that, and then minus you multiply this with that, right? What do you get? You get e to the 8t cosine square t, right? And then plus e to the 4 e to the 8t e to the 8t cosine t sine t. Now this times that, because this is the negative multiplication, right? So minus 4 e to the, there is a 4t e to the 8t cosine t sine t, and then plus, because this is negative multiplication, there is one sign negative, that's why it will be positive, right? E to the 8t sine square t. Now that will cancel out. What you get is e to the 8t cosine square t plus sine square t, right? What is that? That this value is 1, right? So it is e to the 8t. So so this is non-zero, right? This e to the 8t is never 0. That means that w, so u and v are basically what? So thus u and v are the fundamental set of solution, right? Hence the general solution, hence u and v w are the vector u and vector w are the fundamental set of solutions. So the general solution is, what will be the general solution? It will be vector x equals to c1 u plus c2 w. You see that? C1u plus C2w. So what is that? It's because vector x is basically x1, x2, right? And how do you write down that? This, you can write this as C1. What is u? Is e to the 4t cosine t, e to the 4t cosine t, and then C1 4 C1 e to the 4t cosine of t minus c1 e to the 4t sine of t, right? And then plus c2 times the w, right? So what do you get there? There is 4 c2 e to the 4t sine t, and then c2 e to the 4t cosine of t plus c2 e to the 4t sine of 4 also, right? 4c2 e to the 4t sine t. This is the final solution. But our equation is given in terms of y, right? It was y double prime minus 8y prime plus 17y. So we need to find out the value for solution for y. But what is y? So y is x1, right? When we did the substitution, you were doing, the equation was y double prime minus 8y prime plus 17y equals to 0. You are doing x1 equals to y, and then x2 equals to y prime, right? Since you need to solve for y, you need to list the value of x1. So the solution is y equals to, that is the top part only, okay? So you write c1 e to the 4t cosine of t, right? And then plus 4c2 e to the 4t sine of t. This is the final solution of the given equation. Okay, now, so here I want to show you how it looks like if you draw the direction field, right? So how was the equation looking like, right? So the equation we had, after you simplified this, what do you get? You got x1 prime equals to x2, right? And x2 prime equals to negative 17x1 plus 8x2, right? So in the app that I showed you last time, this is the app, right, that you wanted to see the direction field. All right. So here there is no x1, x2. So what I'm doing is x1 is like treating like x and x2 is treating like y. So what can you think about this then? So you can think like, let us see that. So you can think of like, this is y, x2 is y, right? So dx over dt equals to y, and dy over dt equals to negative 17x plus 8y. This is what I did here. You see that? So if you do that, then you get, this is the direction field. Okay, this is the direction field. So how it looks like, if you start here, let's say it goes up. If you start here, look at that. See, it is kind of rotating around the 0. You see that? You see that? Look at that. So it is kind of rotating around 0, right? See, so it is kind of rotating around 0, but since the pointed line segments are going outside of origin, so you can see that it is unstable. Okay, but what is the idea about instability of that, of this equilibrium 0, 0? This is because you see that what were our eigenvalues there? Our eigenvalues were lambda equals to 4 plus minus I, right? See that this is same as like mu plus minus I nu. So what that means is, if the real part of the eigenvalue is positive, then you get that the direction field will go away. It is going out. Okay, it is like, it is also called spiral out. Okay, the previous one was spiral in. When that the real part of the eigenvalue is negative, it was spiral in. When the real part of the eigenvalue is positive, it is going out. That is the spiral out. Okay, that's what we see from this. And we can generalize this. If the eigenvalue of the coefficient matrix A have the positive real part, then you get the origin as unstable, because you will see the spiral out scenario. Okay guys, so this is how we do a problem or a second order linear homogeneous equation by using the pair of first order linear homogeneous equation using the eigenvalue method, where the eigenvalues are complex with real part positive. Okay guys, all right.